This is the Module 2 end of module review. The first question says which expression, remember expressions have no equal sign, is the same as 56 times, so I know I'm multiplying, the sum, which means I'm adding, 14 and 5, so I know I have to add those two together. So when I look through, I see that every one of my choices has multiplication and addition except for this one, so I can cross out letter B. And now I'm going to look at the rest, and I want to find the sum of 14 and 5. So this has the sum of 14 and 5. This does not. And this one also has the sum of 14 and 5. And then it says to go 56 times the sum. I have to find the sum first, so I want parentheses, so I know that my choice is letter D. Question 2, what is the value of the expression, which means that there should be no equal sign, 10 times 154 plus 45. So we remember when we have PEMDAS that we do what's in parentheses first. So I'm going to do what's in parentheses first, and when I add this up, if I need to do work on the side, I can. And I get 199, so now I have 10 times 199. And using my zero rule, I know that 1 times 199 is 199, and then add the 0 back in. Which phrase is the same as this right here, divided by 5. So I know I'm being divided by 5. So every single one of them says divided by 5, so it could be any of those choices. And then I know that when I subtract, I use the word difference. So since I know I need to use the word difference, I can get rid of this one with the sum and this word minus. So first, if it's in parentheses, it tells me that's what I have to do first. So I have to find the difference between 1400 and 300 because those are the numbers that are here. And the one that tells me to do that is A. When I look at number 4, I can do this a bunch of ways. I can try to estimate, or I can actually solve each of the expressions. So if I want to solve 98 times 51, I can go over on the side and solve 98 times 51. And I get 4,998. And then I look over here and it tells me the sum of 17 and these numbers here. And if I have 10 times 10 times 10 is 10 to the third power, or 3 zeros. So when I figure this out, it's this, 1017. So when I look at my two numbers, I know that this is bigger. So since this is bigger, my answer is A. Number 5. If I look at number 5, I can solve them both out using PEMDAS, or I can look at them and say that they both have the same number, in parentheses, the same part to solve, which is the sum of 26 and 9, and both of them are being multiplied, or times 96. So it's the same thing, they're just in a different order, and with the commutative property, I'm allowed to do that with multiplication, which tells me they are still equal. Over here it tells me what's the product. They even give me the multiplication, but remember product means to multiply. So when I look at this, I use my zero rule. So there's 1, 2, 3 zeros. And then I multiply 14 times 3, which is left. And I have 42. And then I have to put in my 3 zeros. So I have 42. And 1, 2, 3 zeros. And if you notice, I do it on the side and then find the answer that matches, which is A. Now it says Manny owns 56 sets of basketball cards. Each set has exactly 541 cards because I'm circling and underlining, and we want the total number of cards he owns. So I always take my larger number and put it on top, or the number with more digits. So I can multiply because each set has 541 and he has 56 of those sets. So I'm going to multiply. And I get 30,296. That answer is there. So there's a good possibility that that's my answer. So the answer is A. Number 8, there are 245 large bags of ice for sale. Each bag has a mass of 40 kilograms. What's the total mass? So once again, I'm going to take my 245 and multiply it by 40. Even though this is a large number, I can use my zero rule and cross that out. I'm actually going to now just multiply what's there. 4 times 5 is 20. Carry the 2. 4 times 4 is 16, plus 2 is 18. Carry the 1. 4 times 2 is 8, plus 1 is 9. And then I have to remember to put this 0 back in. And my answer is 9,800. Notice before I put that 0 back in, they did have that answer. So I have to make sure that I put my 0 back into my answer. Number 9, a history club goes on a field trip to the museum. The price of a student ticket is $15. What's the total cost for 31 students? Once again, I'm going to multiply. I can ignore my zeros and do 15 times 31. And I end up with 465, and I have to remember that I have to put those zeros from the dollars back in, and I have $465. Next, we're going to round the factors, which are the numbers that make up the problem, and estimate the product, which means we want to multiply. So I'm going to round this, and it rounds to 3,000. And I'm going to round this number, which rounds to 7,000. So before I even finish that out, I see that this is the only one that uses those two numbers. So that should be my answer, but I'm going to ignore my zeros. 7 times 3 is 21, and put 6 zeros back in. And my answer matches. I want to make sure it matches all the way through. Number 11, what is the missing divisor in the equation 8 4/10 divided by something equals 84 thousandths expressed as a power of 10? Well, first we're going to figure out how to get from this to this. And if I look at this, if I take 2 jumps, my number would match this right here. Or I can look at it the other way. Either way, it's 2 jumps. 2 jumps tells me it's 100, and 100 equals 10 to the second power because there's 2 zeros. So my answer would be A. Now we're going to estimate our quotient. We estimate our quotient. Remember, we round the second number, which is our divisor, not our dividend. This rounds to 30. When I skip count by 3, what number do I get to that is close to 9 or is 9? And the answer to that is 9,000. And now I can divide. Cross out the zeros that match up, that are the same. And I'm really asking 900 divided by 3. And 900 divided by 3 is 300. Next question. Which multiplication sentence would you use to check the division sentence? Well, if I have this, I can solve it first, so then I can figure out what multiplication sentence I would use. I ask myself, how many times is 25 go into 5, which is 0? How many times can 25 go into 58, which is 2? How many times can 25 go into 87, which is 3? And then I have a remainder of 12. So now in order to check, I know that I would multiply 23 times 25. So that's what I look for first, which is here. And then I would add in my remainder, which is 12. So this answer makes the most sense. Question 14 says to estimate the quotient. Well, this time I just have a 5, so I'm not going to round it. I'm just going to skip count by 5 until I get to a number that's close to 14. And the answer for that is 15. Put 2 zeros and I divide by 5. I now have no zeros in my divisor, so I can't cross any out over here. So I do 15 divided by 5, which is 3. And then I should have 2 zeros. And when I look here, there's nothing that matches because there is a typo. So the answer is 300. So one of these choices should have been 300. So your answer is 300. Number 15, the school photographer plans to place 3,328 photos onto 64 pages of a school yearbook. So we have all these photos being split between these pages. He places the same number on each page. How many photos will he place on each page? So I have to do some division. So first I say, how many times can 64 go into 3? It goes in 0 times. How many times can 64 go into 33? 0 times. How many times can 64 go into 332? Well, a good possibility is that since all these numbers start with a 5 or a 1, it has to be either 5 or 1. It has to be one of those answers. So I'm going to take the 5 and try that. Now I bring down my 8. How many times can 64 go into 128? That's 2. So my answer is 52. And then I can even check on the side to make sure that it comes out to my 3,328 photos. And it does. So now I'm just going to erase this so that we can see the next problem because it went right into the next problem. And the next problem is that there are 1,748 trees to be planted in the park. 76 people will plant the trees. Each person plants the same number. How many will each person plant? So I'm going to do some division again. And once again, now I notice there's a 2, a 3, a 3, and a 2. So I'm going to try one of them and see if one of them works. I'm going to try the 2. And since I know the 2 works, it's either a 3 or a 2. So this time I'm going to try the 3. Oop, I apologize, the page went up. And that works, so it's 23. And once again, I can do a check. And my check comes out to 1,748, so that works out. Number 17, group of middle school students have made $47.74 by selling lemonade. They charged $1.54 for a cup of lemonade. How many cups did they sell? So I have to split it up. This is a little confusing because you're not used to seeing a decimal in the divisor. When you see a decimal in the divisor, all it is, however many jumps to get to the end of it, that's how many jumps I have to get to the end of it. So now all my decimals are at the end and they're whole numbers and I know how to use those. So we divide, 154 cannot go into 4. 154 cannot go into 47. So now I look at 154 going into 477. So I'm going to just try a 3 because some of these choices are a 3 or a 2. And I'm going to multiply and subtract. And then 154 goes into 154 one time. So I see that they sold 31 cups. So my answer was C. And I can always do a check on the side. There are 374 plants in a garden. They're divided equally into 4 rows. About now is telling me to estimate how many plants are in each row. So I'm going to set up my problem that we're dividing. And I'm going to estimate. And when I estimate this, remember this can just stay the same because it's a single digit. And I'm going to skip count till I come to a number that is close to this. So there's 2 ways I can look at this. I think that this should be 360. And my answer would be 90, but I don't see something that matches. So instead of giving up, I try another way. Instead of skip counting by into 37, maybe in this case I should skip count and see if there's something close to that. So if I round that to 400, then I would get 100, and that makes sense. Because there's an answer there. Sometimes your estimate needs to be adjusted and you need to figure out another way. So now solve 745 divided by 70. 70 cannot go into 7, but it can go into 74 one time. 70 cannot go into 45, but I did bring a number down, so since it can't go in, I have to say it goes in 0 times. And my remainder is 45. So my answer is C. Now, of course, we could always do this on the side to check. And it matches. So that tells me that I most likely am correct. And the last one is to convert. Whenever I have to convert, I remember King Henry doesn't usually drink chocolate milk. And we're going from kilometers to meters. So we're going from kilometers to meters. We're going to the right. We're jumping 1, 2, 3. So we jump 1, 2, 3, which makes 6,800. So my answer would be D. And that's my end of module review.